Hello there, I'm Mr. Math Guy, and today we're going to be taking a look at a 10-minute video on inverse relations and functions, and this is actually part 2 of this section. In this section, we're going to take a look at a lot of examples. In part 1, we explained the inverse relations, and in this part, we're going to do more examples. So, in this first one that I have here, I have h of x is equal to x minus 2. And what I want to do is, I want to find or state the inverse rule for this function, or find the rule for the inverse of this function. So again, your notation for the inverse looks like a -1 exponent, but it's not meant to be a -1 exponent. So the inverse of h of x is going to be equal to, now the way that we said to figure out how to find a inverse is you switch your x and your y's, right? You switch them around. So you make this y comma x. That's the inverse. So what we do here is we say, oh, switch your x and y's. So think of this right here as the y, right? Y equals x minus 2. So we're going to say this is x equals y minus 2. We're going to switch that to be a y. Now we want to solve for y. So it's going to be pretty easy here. We're just going to add 2 to both sides. And so our rule for our inverse here, the inverse of h of x is going to be equal to, or excuse me, the inverse. Okay, so we got x plus 2 equals y. Now we simply just replace the y with this inverse. So the inverse of h of x is going to be equal to x plus 2. All right? So if you have h of x is equal to x minus 2, its inverse, or what would undo that, is x plus 2. Now let us show you exactly what we mean by undoing it. All right? So if I come over here on the side, let's say that I have I want to find h of 2. All right? So let's plug it in here. So what is 2 minus 2? Well, 2 minus 2 is 0. All right? Now, if I want to undo this, then I plug it in right here in my inverse function of what I got, and I got 0. And I would say, well, it's 0 coming down to here. It's 0 plus 2, which is 2, and that's the number that I started with, right? So an inverse undoes an operation. It gets you back to the original thing that you plugged in. Let's take a look at another example. If I have g of x is equal to 2x minus 4, what is its inverse? What is its inverse? So if you want to replace the g of x with y, all right, if you want to think of it that way, so you get y equals 2x minus 4. Then to find the inverse, you switch your x and y's. So this is x, and this is y over here to y minus 4. Now we're trying to solve for y. So we would first add 4 to both sides. So we'd had x plus 4 equals 2y. Then we divide everything by 2. You can divide it individually, or you can divide the whole thing by 2. I'm just going to divide it individually here. And so I get 1/2 x, or x over 2, plus 2 is equal to y. Now, replace the y with your inverse function notation. So the inverse of g of x is equal to 1/2 x plus 2. So the inverse of 2x minus 4 is 1/2 x plus 2. So this inverse would undo the function 2x minus 4. Let's do another example. Let's say that f of x is equal to 2x. So just changing some notation around. So y equals 2x, and then switch your x and y. So x equals 2y. Solve for y, and we get, just moving it to this side, y equals 1/2 x, or x over 2. So we can say that the inverse of f of x is equal to 1/2 x. Now, just to kind of show you what this means again, if we take a look at the graph, the graph of 2x is just a line. It's a line that goes through here and has a slope of up 2 over 1. So it kind of looks like this, all right? It's not the straightest of lines. Sorry about that. Now, the inverse is going to be a line that mirror images across the y equals x line. So our inverse would look something like this. All right, it's on the mirror images of what the yellow line will be. Now, a question might be, is the inverse a function? Is the inverse a function? And we would say yes, and we're able to do that by looking at this graph. The blue line is a function, or we can do it by the horizontal line test. Horizontal line test on the yellow line says if it only crosses once or no more than once on the horizontal line test, then its inverse will be a function as well. And you can see if I do vertical lines anywhere on the blue line, most it ever crosses is once, so the blue line is a function as well. So horizontal line test determines whether the inverse is a function or not. Let's take a look at this example. Q of x is equal to 2x squared. So if I want to find its inverse, I say simply just change some notation around and say that's y. Now you switch your x and y. All right, so this is now x equals 2y squared. Now you want to solve for y. So we want to get y by itself, so we divide by 2. So x over 2 equals y squared. And to get rid of a square, we take the square root. And we take the square root of something. Remember, it's actually plus or minus. So y is equal to plus or minus the square root of x over 2. Now, we've also been taught that we can't have a radical in the denominator here, so we would multiply this by the square root of 2 over the square root of 2. All right, and this gives you 2 in the bottom, and this gives you, in the numerator, the square root of 2x. And it would be plus or minus this. So our inverse of q of x is going to be equal to plus or minus the square root of 2x over 2. And you can't cancel these 2's because one's in the radical, one's not. So this would be the inverse of qx. All right, let's say I have two functions. G of x is equal to 2/3 x plus 4, and h of x is equal to negative 3 over 2x plus 6. And the question is, are these inverses? Well, if they are inverses, they would undo each other. So if I plugged a number into g of x, and then whatever I got, if I plugged it into h of x, I'd get back what I originally plugged in. And it'd have to work both ways. So the way that we prove if these are inverse or not is we use our composition function. We simply say this: g of h of x has to equal x, and h of g of x equals x. So let's try the first step. So g of h of x. So this means you plug in h of x everywhere you see an x in g of x. So 2/3, oh, there's an x, so I got to plug in negative 3 over 2x plus 6 plus 4. Plugged in h of x into g of x. Now when I do this, I'm going to get, that would cancel, and that would cancel, leaving negative x, and then 2/3 times 6 is 12/3, which is 4, because you still got to multiply the 2/3 times that, and then plus 4. Now, when I do that, I get g of x is equal to negative x plus 8. If these are inverses, I should get g of x just equal x, not negative x plus 8. So I can stop right there and say, no, these are not inverses of each other. Now, if g of h of x would have equaled x, that doesn't automatically mean yes. You still have to switch it around and then do h of g of x to make sure that one's x as well. So you have to do the composition function or operation both ways, g of h of x and also h of g of x. Thank you for watching. God bless.